Okay, so in our last video we talked about the um, those pseudocode that we needed to solve this problem. So let's talk about how do we actually use it. So let's handle our base case. So I'm going to call this parens, and our base case just has the one thing in it. And if n is 1, return parens. Okay, so now I'm gonna say that we need to have an incrementer, I equals 0, I equals 1 actually, and then we're also going to need to have a set, because we're going to kind of change the size of a set, and so it's, we're going to like loop until we've generated a set that is at n. So current set is parens, but we want it to be a set so that we can just add uniques to it. Okay, so while I is less than n, so we're going to loop until we've incremented to n. That's what this is. Now what we're going to do is the last list that we generated is our current set, right? And so we're going to loop over every element in the last list that we generated. So for permutation in current set. And we also need kind of the last set. So we'll call this actually last set. And we need a current set. So current set equals set. Cool. So for every permutation in the last set, we'll need to loop over the string and insert a fully formed parens in every place in each permutation. So for, let's see, position in permutation. Then what we're going to do is add to the current set as we loop over the last set. So current set dot add, and then what we want to do is get the permutation at 0 to the position. So maybe this is just length 0, or maybe it's, it's whatever. But and then what we'll do is we'll add, we'll concatenate a string in here, a fully formed parentheses, and then we'll concatenate the rest of the string, the permutation from the position plus 1 to the end. So that should give us a new thing inserted in each permutation. And we're adding that to the current set. We're looping over the string and inserting that in every place in each permutation. So once we have completed permuting the last set, building up from the last set, right? We build up from here into the next size up, right? When we say last set equals current set, and there we go. Set the last list to the current list of permutations. So that should help, and then what we can do is return the sorted array of the last set that we made. So let's run that. I don't think it's running, so we'll have to generate parentheses, and let's just generate 2. Let's see, slice indices must be integers or none or have an index method. Okay, so position in range of the length, that's what I did wrong there. Okay, cool, so let's run that. Oh, I didn't increment I plus equals 1. There we go. Oh, I'm not printing it. Okay. Print. Okay, cool. Alright, so that's not everything that we needed to permute. We needed also one side by side. So That's interesting. So let's try it on 3. No, that's not right. Maybe it doesn't need to be +1. Let's try that. Yeah, that's what was wrong there. Okay, so yeah, sorry, I just got my list slicing indexing wrong. And that's how you can compare valid sets of parentheses. So I know I was cutting something off. It's the 3, and then here's 4, and then if we run this here, it looks like we pass all. So that's how we can get the permutations of valid parent, taking each element or each size and growing off of that, and that's where we're backtracking, right? Since we parent set to be the last set, and then we go back over the last set, that's a backtracking action. So we're kind of incrementing up from the smallest size, rather than trying to generate all possible combinations iteratively in a different way. This is a good way to solve this, and you'll see more complex problems use this basic pattern. So that's how it works.